Okay, now we're going to look at how do we perform calculations involving measured data. The key thing to keep in mind is that we don't want to improve the precision of our data merely by entering it into a calculator. So we want our calculated answer to reflect the precision of the data that was input into the calculation to begin with. And in order to do this, there are a couple of rules that we follow in doing the calculation. So we're going to look at those. The first one we're looking at is addition and subtraction. And so basically what you're going to do is you're going to look at the input values, and in this case we look at these three values, and this one right here, the 72.13, the precision of this is less than the precision of the other two values. So this is the one that is going to dictate how we round our answer. And if we look at this, this is saying that basically our estimated digit in this measurement was in the hundredths place. And so our answer to this addition subtraction problem is should only be good to the hundredths place. So that's where we're going to do our rounding. So if we put this into the calculator, this is the value that we get on the screen display. And so what we're going to do, we need to round this to the hundredths place. And so when we do that, we get 112.13 meters, an answer that reflects the precision of the least precise value that we started with. All right. Again, here we have two values that we're adding. These are missing units, so I'm just going to put meters in there with them. And so this one is good to the tenths place. This one is good out to the hundredths place. So this value here is the one that's going to dictate how we round our answer. And when we add those together, this value is what we would get out of the calculator. We're going to round it to the tenths place. The number to the right is a 4, therefore our final answer would be written as 26.5, and again meters if that's the unit that we started with. Okay, now let's look at these, and again let's just imagine we're adding meters here, and we'll make these grams. So we have some units on there. Okay, so we have 235.05. I'm entering this in my calculator, same way you should be doing right now. 2.1. And so my calculator is giving me a value of 256.75. Okay, I have two values here that are only out to the tenths place. Those are my least precise measurements. And so my answer is only going to be reflected to the tenths place as well. So I'm going to round on that 7. Now the number to the right of it is a 5. And when you're rounding numbers, you know, it's typically, if it's above 5, we're going to round up. Below 5, we're going to keep it the same. However, when you have a 5 there, there's a little extra thing you have to keep in mind. And the general rule is that if the number you're rounding is odd, as in the case of this 7, okay, if the number to the right of it is a 5, you're going to round it up. So this would round to 256.8. Okay, if the number had been, for example, 256.85, all right, where the number that I'm rounding to was even, I would leave it the same to round it to the tenths place, and the answer would have been 256.8. The reason that this is done primarily involves calculations where you are dealing with lots and lots of data. And when you're doing this, the way that you round your numbers could conceivably skew your data. And so this particular procedure of rounding up when the number is odd and you have a 5 to the right, or leaving it the same if the number is even, is put in place basically to keep you from skewing your data based on the way you're rounding, okay, which is something that you really would not want to happen. Okay, so let's look at the next one. And I have 58.925 minus 18.2. And I'm getting 40.725. Okay, so now I'm looking at my input values. My least precise number is good to the tenths place. That means I'm going to round on my tenths place. And since the number to the right is a 2, my answer would be written as 40.7. Okay, now let's look at